What up, what up? So, my name is Austin, and my talk is, what are those? Or Ruby percent notation. So before we jump in, a brief introduction. My name is Austin Keeton. I work at Legal Shield as a web developer. We provide basically subscription-based legal insurance. We are an Oklahoma-based company. Our headquarters is in Ada, and if you're at all interested in applying for jobs or checking out our products, you can check us out online. I am also a volunteer and member of Techlahoma in various capacities. If you're at all interested in getting into programming or want to get plugged into the community to help out or to get some support, I would be more than happy to spend some time getting you plugged in. So I'll have my contact info at the very end. Make sure you contact or jot that down and give me a holler. So if you're anything like me and you're new to Ruby, Ruby is pretty weird. Parentheses are often optional. 3.5.floor is a thing. You spend a lot of time doing, but not a whole lot of time using while or other traditional loop methods. But I think most of all, the most interesting, intriguing thing that I've run into so far is Ruby percent notation. So Ruby percent notation generally is a shorthanded way to create strings, to make arrays, to create regular expressions. It can kind of do quite a few things. And so before we get into the specifics, let's kind of go over what the syntax looks like. So any percent notation statement has to begin with a percent symbol, as you would expect, followed optionally by a modifier, and then you have your delimiters. The interesting thing about the delimiters is that although you'll see brackets used most often, that seems to be the convention, you can actually use any non-alphanumeric character, so exclamation points, asterisks, tildes, anything. One thing to note is if you're using kind of these strange delimiters, if you use it in the middle, it's not going to like that. You can escape it and it works. And although this doesn't work, you can see I have unbalanced brackets. If you balance them, it actually will consider that valid. And the same is true for parentheses, curly braces, and the less than, greater than symbols. So I would suggest sticking with the convention of square brackets, but you do have a bit of flexibility with some of the other delimiters. So there's actually quite a few options available for your modifiers. One convention that it seems to follow most of the time is uppercase letters are going to perform interpolation on the contents, while lowercases will not. However, you will see at the bottom there are two exceptions to that rule, so just keep in mind. Don't worry about memorizing this. We're going to jet through all of them. So first of all, the default, if you don't use a modifier, is going to be the same as using a capital Q. And I remember what it does by thinking quote. It's actually just going to place double quotes around whatever the contents between the delimiters are, and then escape any enclosed double quotes. And then since it's capital, it's going to perform interpolation. So let's take a look. So here's an example. You can see that the two prompts at the bottom are very similar. They're just missing the modifier there, but they're going to perform the same thing. So we have a couple of nested double quotes. We have some interpolation that needs to be performed, and at the end we have an escape character for a new line. So if we go ahead and run that, you can see that it ends up escaping those double quotes for us and still performs the interpolation and allows for the escape new line there at the end. So pretty standard, but the nice thing is it kind of makes it less messy to do nested double quotes and things like that. Conversely, if we look at the lowercase q without interpolation, it's going to do something a little bit different. So the same statement performed with the modifier of a lowercase q is still going to escape the double quotes. However, it's also going to escape the hash before the requested interpolation, and it's also going to escape the new line at the end. So it's literally just a string. All right, next up is the capital W. I remember what it does by remembering W for word. What it's going to do is turn the passed in values into array of strings. It's really nice. This is probably the one that I've seen and used the most often. So if you're making a long list, you don't have to put in quotes, you don't have to put in commas. As long as it's space valued, you're good to go. So again, capital, it's going to perform interpolation, so we should see make change there in the middle. And because I'm escaping the space between general and motors, it should accept that as one single string. So if you run it, you can see it creates this nice list for us with a lot less typing. So that's pretty convenient. Lowercase, again, same operation without interpolation. Same content. You can see I took out the statement requesting interpolation because we know that it'll just pop up as being escaped. But you can see that perform the same thing. Next one, lowercase s. This one doesn't have a capital counterpart. It is, I don't think interpolation works. I assume it doesn't. I suppose I should have checked. So we'll take a look. So we have dat boy, and if we run percent lowercase s on it, it's going to convert it into a symbol for us. Identifiers. So this is taking a list of words, and instead of translating them into an array of strings, it translates them into an array of symbols. So I remember this by identifier. Identifier can kind of be a synonym for symbol. So let's take a look. So we have the same as before pretty much. We have, we're requesting interpolation there, and then a bunch of space-separated values. So if you run that, they all get pumped into symbols. As you'd expect, the lowercase, no interpolation, so we just have straight-up words there. Again, a nice list of strings. Pretty handy. Regular expression. This can be kind of nice to simplify regular expressions, maybe. Kind of depends on what you want to do. So it is interpolated, so you can see we're declaring Rx as a small regular expression snippet in the form of a string. And then at the bottom, this is actually from the Ruby on Rails tutorial by Michael Hartle. This is his example for an email regular expression. You can see nested there in the middle in the white is the Rx that we declared above. So when we run that, one thing to mention is you'll notice on the far right, the I, you place any of your modifiers after the closing delimiter. So when we actually run it, it ends up looking just like your normal regular expression. So pretty slick. X, this one's kind of weird. I don't really feel like there's a good moniker for it. So Zerminal, maybe Zonsol or Zamandline. Yeah, any of those. This one I think is probably the most fascinating. I haven't thought of a great use case for it, but if you ever want to run command line within your code and get the output back, you can do that. So you have your standard. Since it performs interpolation, I went ahead and declared -LA to the variable args, and we're passing it into the percent notation, and we get back what you'd expect. You can see that it is new line delimited here. And so if you pass it into a put statement, it goes ahead and gives you the natural layout that you'd expect within your command line. So what's the exact application of this? I think some of them are pretty obvious, like the %W. It's nice for creating shorthanded arrays of strings or symbols for the %I. But other than that, I just think they're a lot of fun. It's not something that I've seen a whole lot used anywhere, but I think in the cases where you can fit it in, it is pretty interesting. So does anybody have any questions?
The X1 seems very dangerous.
Yeah, I don't know. If you can think of something, I'll give it a shot. So. Oh, sorry. He said that the X1 seems dangerous. So. It stands for execute. Execute. Oh, there you go. Nice. I like that. Yeah. I don't know. I really like Zonsol. Yeah. All right. Anybody else? Awesome. Thanks, everybody.